Okay, so periodic table of the elements. Let's start with elements. Elements basically is matter that is made up of only one kind of atom. On the periodic table, you see lots of elements. Here's one, for example, helium, with the atomic number of 2, which you should know means it has 2 protons and 2 electrons. They have symbols that are abbreviations. The first letter is always capitalized. Second letter is always lowercase. Okay, the periodic table. Let's start with the atomic number. It's usually at the top on the element block. It tells you the number of protons in the nucleus. It also tells you the number of electrons. So it tells you protons and electrons. Okay. Here's an example here. A Bohr's model, which is the model of the atom. And let's see, the atomic number for carbon we said was 6. So it should be 6 protons, yellow. 1, 2, 3, 4, 5, 6. So there's 6 protons. Let's count the electrons. 1, 2, 3, 4, 5, 6. So there you go. The atomic number tells you the number of protons and electrons. Okay. Very important you write this down. Atomic number, of course, how you find the number of protons and electrons in an element. APE, APE, atomic number, protons, and electrons. Write this down. APE. Okay, the A is atomic number, P is protons, E is electrons. Okay? So here on that little picture, you see that the atomic number is 9. Which means you have 9 protons and 9 electrons, okay? So don't forget APE, atomic number, protons, electrons, okay? Atomic mass. Atomic mass is the number usually found below the element symbol. It's the total number of protons and neutrons. It's the average mass of the element. Remember, the mass is where the protons and neutrons are in the nucleus. So here for lithium, the atomic mass is 6.941. So that is the mass of the protons and the neutrons. If you're ever confused about which one is the atomic number or atomic mass, the atomic mass is the bigger number, and it's going to usually have some decimals. Like here, 6.941 is a decimal, and it's also bigger than 3. Okay, we said the atomic mass is the number of protons and neutrons. So if we go back here, we can see that 6.941 rounds to 7. So that should mean there's 7 protons and neutrons. Let's see, 3 protons and 4 neutrons. So 3 plus 4 is 7. And you see the yellow nucleus there. That is where the mass of the atom is. Okay? Now, we said APE helped us know what the atomic number is. So when it comes to finding the number of neutrons, it's not written down here, but if you'll write down man, M-A-N, man, okay, M stands for the mass number, okay, A stands for the atomic number, and N stands for neutrons. So I'll go over this in class with you, but if you had the M was the mass number, here the atomic mass is 10.811, so if we round that, it'd be 11, right? So the mass number is 11 minus the atomic number, which is 5 here. So what's 11 minus 5? 6, right? So 6 is the number of neutrons. So M-A-N, M is mass number, A is atomic number, and N is neutron, and that's how you find neutrons. This is the same thing right here. So neutrons equals atomic mass minus atomic number. Okay. Now some of y'all are going, what is the difference between the mass number and the atomic mass? Well, they're basically the same thing. If you look to the right here for carbon, you'll see that carbon has an atomic mass of 12.01. Remember, that is the mass of the atom. It's where the nucleus is. So it's your protons plus your neutrons. The mass number is just the atomic mass rounded to the whole number. So here we have 12.01 is the atomic mass of carbon. Look down at the bottom left. The mass number is 12. We just took 12.01 and rounded it to 12. Okay? So if 12 is the number of protons plus neutrons, let's look and see if that's right. Look at the Bohr's model of the atom down there. Let's count the protons. 1, 2, 3, 4, 5, 6 protons. Now count the neutrons. They're the blue ones. 1, 2, 3, 4, 5, 6. So what's 6 plus 6? 12. And the mass number is 12. Okay? Okay. Periods. We're getting to the periodic table now. Periods are the rows of elements whose properties change gradually. So they're going to go left to right. The picture is pretty self-explanatory here. You're just going left to right. And remember, when you move left to right, what happens? The mass increases. It gets bigger. You have more protons, you have more neutrons, and you have more electrons. Period 1 has 1 energy level. Okay, so 1 circle where the electrons are. Period 2 has 2 energy levels. Period 3 has 3 energy levels. Okay? Now this, everybody should know, groups. Groups and families. Groups go down. Okay? They're like columns, each with a family of elements that have similar properties and behave in a similar way. So remember that these groups are also called families, and they behave in the same way, just like your family might behave in the same way. The elements are arranged going up and down, and we'll discuss later. Valence electrons, very important you know that. The first group has 1 valence electron. The second group has 2 valence electrons, and then we're going to skip to group 13. And in class, I told you to just kind of pretend there's no 1 there. So if you hide the 1 for 13, you have 3. So group 13 has 3 valence electrons. Then, of course, group 14 has 4, 15 has 5, 16 has 6, 17 has 7, 18 has 8. So you get the idea. Okay? So this is probably the most important word in your notes today because it's new to you. Valence electrons. They're located on the last or the outside energy level. Okay? We just told you the group number tells you how many there are. So here at the bottom you can write this down. Group 1 has 1 valence electron, and group 2 has 2 valence electrons, and group 13, forget the 1 for a second, has 3 valence electrons. This picture right here, you need to write this picture, draw this picture. It's really good. It shows oxygen here. And if you notice, there is, I think, there's 8 total electrons. But how many valence electrons? Well, you're looking at the outside shell or the outside energy level. And they even have them counted here for you. 1, 2, 3, 4, 5, 6. So there's 6 valence electrons. Okay? I would love for you to actually put numbers and count those on your test or on your quiz. Okay? Now, this to me is so simple. Okay? It's saying my battery is almost dead on my computer, so I need to plug my computer in real quick. So if you'll give me a quick 10 seconds, I'll plug my computer in so it won't die. Okay, so I'm back. Okay, the electron dot diagram should be easy because you had this on your gizmo in the computer lab. So all it is, it's a diagram that shows the number of valence electrons of an element. So here's oxygen. Okay, we just showed you that there are 6 valence electrons for oxygen, right? So notice how many dots are there. And those dots represent electrons. So 1, 2, 3, 4, 5, 6. 6 valence electrons. That's all it is. Okay? Just remember, they're not electrons, they're valence electrons. Okay? Okay. We're almost done with our notes today. This is a review. I think it's from 6th grade, metals, nonmetals, and metalloids. So, very quickly look at the picture here. The blue is metals, the green is metalloids, the ugly mustard color is nonmetals, okay? So let's discuss metals first. Metals, they're located on the left side, and most of the elements on the periodic table are metals, right? They're shiny. If you have a brand new quarter or a brand new penny, it's shiny, okay? They're a good conductor of heat and electricity. When you charge your cell phone, inside of your cord, it's metal wiring, and that's going to provide electricity to your phone to charge. They are solid at room temperature. Okay, if you notice on our periodic table in the room, all the letters are black, with the exception of mercury. So that would be a good bonus question for a test. What is the only metal that is not a solid at room temperature? It's mercury. It's Hg. I think it's in group 12. Okay, malleable. Malleable means they can be shaped. Okay, they can be. You can change them, you can bend them, and they're not going to break. Okay, and then ductile just means what I said earlier. You can make it into wiring. Okay, to carry electricity through it. So ductile is drawn into wires without breaking. Okay. Nonmetals on the right side, usually gases. Not all of them are, but usually gases. You do need to know this. This would be a great bonus question also. Group 18, I think it's helium, neon, argon, krypton, xenon, and radon. Those are all gases. Group 18 is called noble gases, and I bet some of you already know that. But I put a little note here. Noble gases are group 18. They're dull in appearance, so they're not shiny. They're kind of like, just boring. They're just dull. Okay. Brittle, which means they break easily. Okay. And something interesting here is that 96% of the human body is made up of nonmetals. Okay. Think of oxygen. We have carbon. Okay. Those are very, very important things you need to know. Okay, and finally here, metalloids. Metalloids. These are confusing sometimes. Basically, what you need to know about metalloids is they're kind of a mixture between metals and nonmetals. Okay, they're found along the zigzag line between metals and nonmetals. You can see them in green. They share common properties of both metals and nonmetals. A semiconductor it's not a conductor, it's not an insulator, it's a little bit of both. It has a little bit. It allows some electricity to go through it, and it kind of stops some too. Okay, and they're sometimes called semi-metals. Okay, so these are your notes, and make sure you study these notes, and make sure you're aware about valence electrons. Very important, you know that. And then you need to do your questions in your summary. Although I will tell you, it's better to wait till tomorrow or the next day to write your questions in your summary. That way you can review your notes again, okay? But we will check these notes on Monday, which I think is, let's see, 15th. Well, I'm not sure what day it is, but I know it's next Monday, okay? So make sure these notes in your notebook on page 29, okay? I'll see you guys in class. Have a great day.